Hi there, 8th grade students. This is week number 12 of e-learning. That means it is the second week of the second marking quarter. We're just going to carry on from what we were doing last week. Last week, you watched my daughter make some molecules using gumdrops. Now remember, each individual gumdrop represented a different element found on the periodic table of elements, and each element is different from the other by its atomic number or the number of protons. So she took these gumdrops, and this represented a water molecule. And this water molecule, I have H2, so 2 hydrogens and 1 oxygen, and she strung them together using toothpicks, a single toothpick on each side. Please notice the shape. I'm going to flip it upside down, and oftentimes this water molecule looks a little bit more like this. They call it the Mickey Mouse molecule. They say that a water molecule looks like Mickey Mouse. Do you see the ears? See Mickey Mouse's face? Anyway, that's a water molecule. A carbon dioxide molecule has a different shape, however, and it had 2 toothpicks on each side bonding the oxygens to the carbon, which was in the center. This is CO2, this is H2O, different shapes and different strengths of bonds. That was old material that I've been hammering at you for quite a while. This week, let's review mixture molecule, which I briefly introduced last week. Need to talk about physical and chemical differences with our different molecules. And then I want to talk about producing a synthetic material from these natural elements. And then kind of taking a look at, first of all, why do we produce these synthetic materials? What's their purpose? What's their impact on society? So let's review mixture versus molecule. See all these individual elements, which are atoms, but these individual elements are gumdrops and all the sugar that was around them. They are in here. They are not bonded together. Therefore, this is a mixture. This is a mixture. If, however, I take the molecules that my daughter made last week and I put in a water molecule, and I put in a carbon dioxide molecule, and I put in a couple more water molecules that she made. Oops, then I throw them all in there, and I shake them around. This is also a mixture, because this is a mixture of water and carbon dioxide molecules. If, however, I only have my 1 water molecule in here, this is a molecule. But when I mix it with a bunch of other molecules, now I have a mixture of molecules. All right, hopefully that kind of makes sense. Talking a little bit more about this idea of a molecule, I want to take a look at some physical properties of the different molecules. Now, I told you this water molecule has a certain shape. That shape is a physical property. We can physically see that shape. What causes it is the way the bonds hold it together. I want to talk about a natural element on the periodic table. It has 6 protons, therefore, it is a carbon atom, or the element carbon. And carbon makes up the stuff found inside this pencil. The stuff that makes this pencil write on a piece of paper is called graphite. And graphite is made of carbon. I got something else that's made of carbon, and it's made solely of carbon, but it doesn't look like graphite, and it costs a little bit more than graphite. It is the diamond that my husband gave me when he proposed to me 20 years ago. Okay, graphite in your pencil and the carbon found in my diamond, the carbon in graphite and the carbon in my diamond are exactly the same element. So what makes them different? It's the way they are physically arranged. So let's start with the carbon found in graphite. Graphite. I'm going to put a whole bunch of carbon atoms like that. Those lines in between represent the bonds. Graphite is lined up in these sheets. And there's another sheet of carbon right underneath the first one. And these are also bonded together. So what keeps this sheet attached to this sheet? It's another bond, but it's very, very weak. And I'm going to represent a weak bond with some dots going down. Those super weak bonds between this sheet and that sheet allow me to take my pencil and scribble on the bottom of this paper. And every time I swipe across the paper, it's peeling off layers of graphite, okay? Or it's peeling off a layer of carbon. Graphite is a very soft mineral. Let's take a look at a diamond. So a diamond, also made of carbon. So I'm going to have a carbon atom here. And I'm going to have another carbon atom here. I'm going to put two lines representing a much stronger bond holding them together. There's another carbon above it, but it is also bonded to those two carbons with the very strong bond. So it's not going to peel off in sheets. In fact, there's another carbon right here that's bonded like that. And all of a sudden, I'm creating this structure with these strong bonds on all sides of it. And the physical properties of diamond are that the carbons are bonded or attached on every side in every direction with these strong bonds, whereas the physical properties of graphite make it soft, the physical properties of a diamond make it very, very strong. So the physical properties really are a result of the way those atoms are arranged inside. Some chemical properties. Chemical properties are if we were to add another type of element. So I have to laugh because people, it was all the rage a few years ago. It was, if you really love her, you'll buy her a chocolate diamond. A chocolate diamond? You mean like a candy diamond? I might like that, but a chocolate diamond? It was a diamond that people were buying for their loved ones, but the diamond was, it was like a brownish color. Now, it was lovely, but what people have to realize is there was an impurity in it that caused it to be a different color. There was a chemical change, and it may have been a silicon element. The element silicon may have bonded in there to give it a little bit of a different color. I'm trying to think what else. Titanium, the element titanium. Another, they call it an impurity, but all it did was it causes the diamond to have a little bit of a different tint, keeps it from being clear. Again, by putting these impurities in, the diamond has it still is beautiful. However, they were jacking the price up of these diamonds so that they were twice as much. And really, they were diamonds that would have been considered undesirable 5 years ago. And nowadays, they're touted as, if you really love her, you'll buy her the chocolate diamond. So don't get suckered into that media craze. So I guess that kind of leads me into this project that I want to do, all right? Physical versus chemical. Chemical properties are when we start to add additional elements to it and we change its chemical composition. Last week, you guys watched my daughter. She took Elmer's glue. she mixed it with laundry soap. She took glue, which is made up of a bunch of natural elements, and she combined it with laundry soap, which is also made of natural elements. But what she got was slime. She got a whole new substance. Whenever we add different elements together, we get a whole new substance. We have to change the name. So this week, we're going to take a look at, in this project, synthetic materials made from natural products. Why do we want to do it? Give me a second. I'm going to share my screen. So you recognize this thing as the periodic table of elements. In our next slide, we're taking a look at the chemical composition of Elmer's glue. And I think I showed it to you last week. Elmer's glue is made up of these natural elements, carbon and hydrogen, more carbon and hydrogen, oxygen, carbon, carbon, and hydrogen. And the little numbers after are just telling us how many of each of those elements are combined together. This whole thing together, voila, gives us Elmer's glue. Okay, so this synthetic material is made from these natural elements. So if I hop over to the project that I'm asking you guys to take a crack at this week, let's look. Our directions say for this summative task, you will be reading, gathering, and synthesizing information, evidence to answer the following questions about the synthetic product of your choice. So you guys are going to have to choose a synthetic product. I give you some examples. Woo, I went way too far. I give you some examples here. I mentioned like Jello, nylon, polar fleece, cement, plexiglass, plastics. You could even do Elmer's glue if you want. That would be great. Here are the questions we're going to tackle. It says, what is the synthetic material? Well, that one's quick and easy. Maybe you choose Elmer's glue. Maybe you choose the material like nylon, whatever your face mask is made out of. What is the importance to humans? So you might need to do a little bit of research online. Why do humans use it or make it? Well, I know that Elmer's glue gets used in schools all the time, and it allows two things to stick together, but it doesn't hold stuff together like I wouldn't trust it if I was trying to stick a cement block to the ceiling. I wouldn't want to use it. So it has a purpose, but kind of, for weaker sticking things together. But I would look up online, why did we first start making Elmer's glue? What natural resources, the third thing, what natural resources are used to make this Elmer's glue? And again, yours could be nylon, it could be tons of different things. You've got to go online and start searching and reading. Okay, what's used to make this? What are the atomic structures of the reactants or the natural resources? Well, so I would look up Elmer's glue and I would look at the carbons, hydrogens, oxygens, and I would look at how they were arranged. How is it made? You're going to have to dive into what is the process in the factory that makes Elmer's glue. And the last thing you're going to do is you're going to look up at the negative and positive impacts or effects of making and using Elmer's glue, compared to, say, making or using a more natural material with a similar function. You could go out to a pine tree and find pine sap, and that holds stuff together. If you've ever sat in pine sap or stepped on it with your shoe, everything sticks to it. Why don't we use that instead of Elmer's glue? That pine sap is naturally occurring, oozing out of the pine trees. Right? So this is the first thing you have to do this week, is you've got to research these questions. Once you've completed your research, I'm asking you to make like a poster. Now I realize you're at home and you might not have the resources. I do not want you to go to the store and go buy a ton of stuff for this, all right? Because we're not in school, I can't hang it up in the hallway. So you might just be drawing it on a piece of paper, or I can show you a way to do it on the computer. I want you to organize all of this information onto a poster. I would like to know where you got your sources from, so make sure that you're highlighting, copying and pasting the URL where you got your information, because we got to make sure that the evidence is reliable. And I'm looking for it to be neat, professional. Here's an example of one. Now, this is one that a student did. I pulled it off online. They had weeks to do it. They were in school. They had their teacher right there to help guide them. They did it on the computer. They did it in, not in PowerPoint. They used Publisher. And you guys do have Publisher on your computers. But we can see they were studying gummy worms. That means you guys can't use gummy worms. You can't use gummy worms at all, because I'm giving you an example with gummy worms. So it says the natural resources used to make those gummy worms, they give you the ingredients: sodium alginate, calcium chloride. And then it tells you sodium alginate is made from seaweed. Yum, you're eating seaweed when you eat gummy worms. Calcium chloride is made from limestone. Limestone's in the rocks that you find in Allegheny in the park. They talk about how gummy worms are made. Now you can see it's not a humongous report. You can bullet your items. They're showing you the chemical formulas, the way the atoms are arranged. And remember, those lines represent the bonds in between the calcium and the chlorine, and the OH and the NAs, which are the sodiums. You can find this online, okay? They're showing you kind of the chemical reaction, what happens when you put them together. Human use. Humans use gummy worms as a sweet snack that's enjoyed by adults and kids. You're right. That's our human use. That is the whole purpose of gummy worms. I mean, maybe they're used for bribing people to do things, who knows? But they were originally made as a snack. So the impacts on society. Are there negative impacts from gummy worms? Well, I suppose they have to go harvest the seaweed out of the oceans. So if you take seaweed out of the oceans, you've taken food away from the ocean animals. So harvesting takes away food from sea creatures, results in health problems if it's eaten too much. Is that too much by humans? I guess no more seaweed sushi. Positive impact. Kids love them. Adults love them too. And they're easy to produce in bulk. So this is information somebody found online. Taking a look, and they're comparing it against, say, fresh fruit. Why would you go for gummy worms over fresh fruit? Fresh fruit, negative impact. Growing fruit trees requires deforestation to clear the land, pesticides to keep the bugs from destroying the crops. Machines could be used to harvest, which could add pollutants to our environment. Some positive impacts. Well, fresh fruit is a natural substance, therefore it's considered more healthy for you. It has vitamins, minerals, and people enjoy them. And honestly, your body can digest fruit a whole lot easier than it can digest gummy worms. But quite honestly, gummy worms are really yummy. And fruit is yummy too, but gummy worms are really yummy. This person gave a lot of citing of their information. And last, which is better for society, worms or the alternate, or the natural alternative, which they had given as fruit. Said both gummy worms and fruit slices have positive and negative impacts. Because gummy worms are partially made using a non-renewable resource, I think gummy worms, negative impact is greater. Fresh fruit slices have a greater positive impact because of its health benefits to humans. Because of these reasons, I think fresh fruit is better for society. Purpose of the project, I want you to get on and do a little bit of research, making a synthetic or a non-natural material from natural materials in the environment. Okay, so on our class pages, I give you a bunch of examples. I'll continue to add examples. Let's see if I can quickly find my class page. No, I can't quickly find my class page, sorry. So anyways, I will see you guys Monday morning, 9 o'clock. Looking forward to it. We have to do a little performance matters assessment. It's 10 questions, and then it's making sure that you remember the parts of the scientific process. We will quickly go through that together, and we'll talk about this project on Monday. So I will see you guys later. Pop into the office hours. Bye.